Hello, in today's lecture, we are going to study the basics of exercise 1.5. In the previous video, we did the basics of 1.4. I hope you have solved the exercise 1.4 and you have no problem in that. Okay, so our today's topic is complement of sets. Okay, like we have studied complementary angles. Complementary angles. What are those? These are two angles whose sum is 90 degree. Okay, suppose let one angle is given to us, say x, and we are supposed to find another angle. What do we say then? We say the complement of this. So complement of angle x is equal to what? It will be 90 degree minus x. Now look, if x is 20 degrees, it will be 70 degrees. If it is 30 degrees, complement will be 60 degrees. Okay, so what do you understand from here? That complement is something that is not included in our given value. Okay, we are given 30 degrees, so these are those 60 degrees which are not given in our this value and whose sum make it equal to 90 degree. That is required to us. Similarly, in complement of sets, complement of sets, the set which contains all the elements of universal set that are not contained in a given set. Okay, you can understand this by example. So let us assume we are given u as 1 2 3 4 till 10. Okay, and a set is given to us as a, that is 1 3 5 7 9. And now we have to write complement of a. Complement of a. Complement of any set is represented by the set with the dash. Okay, and we say it a dash or complement of a. This will be what? All the elements of u that are not in a, that are 2 4 6 8 and 10. Okay, I hope you understood it. Also you can say that a dash is equal to u minus a. Okay, means all the elements of a u that are not in a, the same it means. Okay, Now an example is given in beginning of this complement of set about this topic, that let U be the universal set which contains all prime numbers. Okay, U is given to us all prime numbers. Okay, this we write in tabular form x. This we write as x. X is a prime number. Okay, this is our U, and A is subset of U, and A contains the prime numbers that are not divisors of 42. Okay, means all those prime numbers which are not able to divide 42 completely. Okay, now we know if we divide 42 by 2, we will get 21, completely divisible. Now 42 divided by 3, we get 14, completely divisible. 42 divided by 5, it is what? It is 8.4. It is not completely divisible. Now next prime number is 7. This we get 6, and further no more prime number is there that divide 42 completely. Okay, so what do we get is these three numbers 2, 3, 7. Does not belong to A. Okay, why? This we all know that A is a set where X belongs to U and X is not a divisor of okay. So A, what will we write? A will be 5, then 11, 13, 17, 19. This is only leaving these three prime numbers. All the prime numbers will be included in set A. Okay, and to represent these three elements we use A dash, that means complement, and this complement will include only these three elements. Okay, I hope you have understood it. Now some properties of complement sets. Okay, now again about these also we will study properties. First, complement laws. First is A union with A dash will give you U. Okay, we can understand it by using Venn diagram. Okay, it is our universal set U. It is our set A, and leaving this, all the elements of U will be included in A dash. Okay, now we have to do union. First of all, we will take set A and then the A dash. A dash is this. So you can see that complete this rectangle that represents universal set is shaded. That means A union with A dash will give you U. Okay, now second is A intersection. A intersection with A dash will give you 5. 5 means no element. That means if we take intersection of A and A dash, we will not get any element coming from both. Okay, it is obvious because this contains all the elements that are not in A. Okay, that's quite easy. Now you can, it is just to, if these are remembered, most of our questions can be easily solved. Okay, now second is, it was our A part. Second is B. De Morgan's law. De Morgan was a mathematician who by experiments gave us two laws. First one was A union with B dash will be equal to A dash intersection with B dash, and second was A intersection with B dash is equal to A dash with B dash. Okay, these are quite easy but somewhat difficult to understand without Venn diagrams. So first of all, we can use Venn diagrams. Okay, it is my universal set U, and I have two sets A and B. Okay, now what is A union B? A union B will be this area. Okay, now what will be A union B dash? Those elements which are not included in this area, means this. Okay, it was our left hand side. Now for right hand side, now in this I am going to draw two things. A dash, first of all, in this A dash, it is my A, this is B. What will be A dash? All those elements that are not in A, means leaving this set, this much area, everything. Okay, B is also included in this because many elements of B may not be in A. Okay, now if I draw for B dash, again here this is U, it is A, it is B. Now what will be B dash? Leaving this every part of universal set in this A is included. Okay, and now if we check this and this, and take its intersection, means what is common, then what you will find that leaving A union B means this much area, you will get other area common. Okay, in this way he found out this. And similarly, if you take this, then we can easily, using Venn diagrams, you can understand it easily. So you yourself have to make these Venn diagrams and understand, so that this will be clear to you on your own. Okay. Now other properties are, third is A double dash is equal to A. Okay, how? First, what is A dash? A dash is U minus A. Okay, and if I again do its dash, that means what? U minus A dash, and that will be U minus A. Am I right? Okay, like in this, I have to do the complement of this set. So I had to subtract this set from universal set A. Universal set. Similarly, in this case, I have to find complement of this set. So I have to subtract it from my universal set, and this will be what? U minus U plus A. That gives me. So that means A dash whole dash means A. Okay, understood. Now fourth is quite easy. That is D. Phi dash. Phi means nothing, and its complement will be what? Everything. Everything but means what? Everything means our universal set U. And similarly, if we do its opposite, that means universal set complement we have to find, that we will get phi. Why? Because every element is included in our universal set U. So if we take its complement, what we will get? U dash will be U minus U, that means 0, that means phi. Okay. Now this was all our basics of 7.5. We can now try some of our questions. First of all, see question number 4. Question number 4 and 5 are somewhat important from this exercise. In question number 4, universal set U is given to us. That is first 9 natural numbers, 7, 8 and 9. Okay. And two sets are given to us, A and B. A include elements 2, 4, 6 and 8, and B contains elements 2, 3, 5, 7. Now using these, we have to verify our De Morgan's laws. Okay, that we have studied. First one is A union B dash is equal to A dash intersection with B dash. Okay, this we can, first of all we will find A union B. That will be what? First we will write all the elements of this, 2, 4, 6, 8. Now we will check what are common. Only 2 is common from here, so leaving 2 we will write all the elements of B, 3, 5, 7. It is our A union with B. Now if we find its complement, means A union B dash, that will be, from U we have to not select these elements, So what I will get? 1, 2 is in this, 3 is also there, 4, 5, 6, 7, 8, and then is 9. Okay, one side is cleared. Now another we can solve here. In another, first we have to find a dash, means first we have to do complement of a, that will contain elements except 2, 4, 6 and 8. Okay, that is 1, 3, 5, 7, 9. And if we do b dash, we will get 1, 4, 6, 8, 9. Okay, and if we do its intersection means we have to take elements that are common in both, then we will get 1, 3, no 3, 5, 7, then is 9. And we can see clearly that this is equal to this. Okay, that means our first De Morgan law, that is A union B complement is equal to A complement intersection with B complement. Okay, similarly you can prove second. I think it is very easy for you. And question number 5 is draw appropriate Venn diagram for each of the following. These Venn diagrams we have drawn already while we were studying the De Morgan's law. Okay, so you can do this on your own. So your homework is to solve examples of exercise 1.5 and exercise 1.5. Okay, thank you.